So we're going to start with the flashcards. Okay, so log base 3 of 9. So remember, that'd be 3 to the third. So try again. 3 to the what power is second. So this one's going to be 2. Good. Log of 10. Remember, it's log base 10, if it doesn't say it, of 10. So 10 to what power is 10? 1. What happens here? Remember, this is a negative. It's a no solution. Anytime no matter what this log is, even if it's an ln, it's a no solution. So it's a null set. How about this one? 7 to the log base 7 of 15. This is one of the properties that is just going to be 15. So when your base is the same here, and then it's to a power where it's a log of the same base, then it's always going to equal to the 15. So in this case, 15. Now this one is 2 to some power, but since it's it's a fraction, that tells you that it's going to have to be a negative number. So 2 to what power is 16, and make it negative. So 2 times 2 is, yeah, correct. 2 to the third is 8, so one more fourth. Good. So it's going to be negative 4 since it's going to be a fraction. So negative 4.
That's the undefined.
Undefined. Good job. You caught it. Okay. This is saying 9 to what power is 1? It's 0. Anytime this number in here is 1, no matter what your log is, it's always going to be 0. 7 to, oh, same problem, isn't it?
Yeah,
0. Good.
7. No, oh my gosh.
Right. You got the right idea. It's 7 to what power? You're taking 7 times 7, which is right. But 7 to what power would be 40? Second. Very good. Very good. Super duper. Okay, it's 1. So the log base e of, and since this is 0, yes. The e to the what power is that? So this one is, remember, it's always log base 10 if it doesn't have it. So 10 to what power? 3. Mm-hmm. Keep small. So 3, yep, to the third. Perfect. Now this is saying basically the same as log base e of e. So e to what power is e? 1. Oh, same problem.
1.
Different. Now this one is going to be different because of the number and the log is larger. So the base is larger. So this tells me that it's a root. So 25 to what power? Like the square root of 25. So how do you write the square root as a fraction or as a power? Yeah, it is the square root of 25. Let me just write it here like this. We'll start with this one, just review. So this means you're going to have the square root of 25 because it's going to equal 5. But that's 25 to the 1/2 power. So it's going to be the root then. So that would be then 1/2. Same thing with this one. This one's bigger than 2, so it's a root. So remember, 2 to the 4th power is 16. So the 16 to the 1/4 power would be then 2. And this one, okay, this one is, when it's a decimal, it can be also written as 1 over 100. So this one is log base 10, and it's going to be 10 to what power is 1 over 100? 100. So start by 10 to what power is 100 and making it negative. Yep, negative 2 is your answer. Good job. So we'll just keep going over those occasionally because I do think it helps to have kind of a pretty good understanding of what your logs basically mean. Plus, man, that would have helped you for Quiz Bowl probably. But All right, today we're actually going to talk about a unit, and we delved into it just slightly, like we got our toes wet with it on when we did the 4.1 when we change from our exponential form to our logarithm form, because I know that one of the problems we solved was we changed the bases so they're the same. But this is going to be, let me just go ahead and review. So if we go to the log form, and this was from section 4.1, and it was in the form, let's go ahead and just change it to log base b, and I'm going to go ahead and say this is going to be of x is equal to y. And I can put m and n here. A lot of times you'll see that in the same, but we can put any variables in there. So if I change that to the exponential form, that means that I'm going to take my base. Remember, all logarithms are going to be, that's what is an exponent. So every time you see a logarithm, you're thinking in terms of exponent. So this is written as b to the y is equal to x. And so when we do that, so when you have your test on this one, this is one that I would, if you're not real comfortable with, make sure you have it written down, because this is a lot of what we're going to do. But this is saying that our formula, or one of the properties that we have, is that if b to the m is equal to b to the n, in other words, the bases have to be exactly the same, that means that the m is going to equal the n. And so it kind of makes sense in some ways when we've had, like, if we had 3 to the second power is equal to 3 to what power, then you'd obviously say, well, this has to be 2 because they have to be the same. And we had a problem similar to that. I think I said 4.1. It was actually 4.2, I think. But what we want to do on this problem is change and make sure that our bases are the same. And sometimes they're a little harder than to think about. But in this case, I'm going to start, I forgot 5 to the 2 minus x power. I need to change 1 over 25 to something that is 5 to some power. So in other words, I'm going to start off with 5 to what power is 125. So we start off with 5 times 5 is 25. Times 5 again is your 125. But because it's on the fraction, it's a fraction, that means that this actually needs to be to the negative third power. That makes sense? Okay? And so if I have 5 to the 2 minus x power is equal to 5 to the negative third power, that means that for my property before, that these two powers have to be equal to each other. So then I can just set it as 2 minus x is equal to a negative 3, and I could go ahead and solve. So in this case, since x is already, it's negative, I try and kind of keep that the coefficient in front of my x positive, but I'm going to go ahead and change that rule this time because it's all by itself. So I'm going to minus 2 and minus 2 on both sides. So I have a negative x is equal to a negative 5. Therefore, the x has to equal 5. And so if you think about, if we put that right back into our equation, and I said, well, 5 to the 2 minus 5 power is going to equal then 125. Then it would change, well, 5 to the negative third power does equal 125, so it checks out. The second type of property that we have is going to be that what we will do is we'll isolate the exponential expression. So we're going to use logarithms to solve the exponential equations. And our steps are going to be that we're going to isolate the expression that has the variable in it. So in this case of my first example, when I have 5x to the x minus 3 power, it's already there. Then we're going to take the common log or on both sides of the equation in base 10, or take the natural log on both sides of the equation in base 10, and then we're going to simplify it. Because you could actually take the log of both sides just as long as you keep them the same. And we're going to do the first one both ways. But you should get the same answer. So in the first one, I'm going to do the ln. I'm just going to put ln, and then we're going to also do the log. Okay, I'm going to start with, on this one, if I have 5x to the x minus 3 power is equal to 137. Then what I'm going to do is take the ln of both sides. So I'm going to have the ln of 5 times x minus 3 is equal to the ln of 137. Now, a couple of things that we can apply as I grab my calculator, which I didn't have out to begin with because I knew I was going to do logs. I should have had it out. The log of 137 is not going to be a whole number, but I'm going to keep it in my calculator. I also know that I'm going to go ahead and, since this is to the power, so it's the ln of 5 to the x minus 3, and it says I can pull it right out in front. So what it means is that I'm x minus 3 in front times the ln of 5 is equal to the ln of 137. Now our book suggests that we go ahead and solve for x at this point, and keeping it as the ln of 5. So if I divide both sides by the ln of 5, and divide this side by the ln of 5, then I'm going to end up with then x minus 3 is equal to the ln of 137 divided by the ln of 5. And then I'm going to add my 3 to the other side. So x is going to equal this ln of 137 over the ln of 5, and then I'm going to go plus 3. Now at this point I'm going to grab my calculator. I'm going to go ahead and do that. So I'm going to do the ln of 137. I'm going to go ahead, you can put it all together as long as you put some parentheses in. But I'm going to show you this one is going to be then the same as 4.9199. Now with logarithms on this front, I need you to have a calculator that you can arrow up to select it. Because even though we take it to the 100th place, if you round now, you'll probably struggle with getting the correct answer. So then I'm going to have the ln of 5, and I'm going to go ahead and equals, and that's about 1.609. And so then what I'll go do, I will arrow up and highlight my ln of 137. And I'm going to divide it by then my ln of 5. And then I need to just add plus 3 to solve. And so my answer then for x is going to be then 6.0. Let's go ahead and round to 3 decimal places. So it'd be 6.57. Now again, if I did the same thing with the logs, I would still have the log of 5x minus 3 is equal to the log of 137. And so even though my bases are different, you're still changing it to the power, and I'd still do the same thing. I would move this out in front. So I'd have x minus 3 is going to equal the log of 5. It will equal the log of 137. Divide by log of 5. And then I'm going to add 3. So I ended up going x is equal to the log of 137 divided by the log of 5 plus 3. So grabbing my calculator again, I would take then the log of 137 divided by, and I'm going to put it all together, the log of 5 equals, and then I'm going to add then 3. And so x is still going to equal 6.057. So I went through that one a little faster, but notice that they're same. So as long as you can either take the ln of both sides, or you can take the log of both sides, as long as you keep them the same. I would never. The definition on solving. So again, going back from my logarithmic form to my exponential form, when I have a problem like this, if I don't have logs on both sides, that means I need to go ahead and put it into exponential form. So when we did this before, remember we said the log base is the number down below is of m is going to equal c. So in other words, it changes to b to the c is equal to m. So now right now my m is just the 4x plus 1. It's all of that. So I'm going to start off, I still have a base. Which is my base on this problem? On 2, right. So 2, remember this is going to be my exponent. So 2 to the 5th is going to equal 4x plus 1. Good job. And then I'm going to simplify it. So 2 to the 5th, grab your calculator if you need to, but 2 to the 5th is going to be then that 32. And then is equal to 4x plus 1. And then I'm going to subtract my 1 from both sides. And I'm going to end up with, then I'm going to come right over here since I'm running out of room. 31 is equal to 4x. And then I need to divide both sides by 4. So x is equal to 31 divided by 4, which would be about 6 1/4, or 6.25. Or 7. 7? What? Okay, yes, 7. Oh, yes. You know what I did? I'm sorry, I divided it by 5. So, anyway, but yes, I am dividing it by 4. And so it's going to be 7.75, not what I just said earlier with 6.25. That's why calculators are important. So the next one on this one, if you notice, I have 2 logs on both sides, on the left-hand side. And in order to do that, I've got to get this isolated so I have just one logarithm expression, or I can't solve it. So to start off with, I need to remember my property. When we add logs, that means what you're doing is you're multiplying inside. So this can be written as log base 6 of x plus 3 times x plus 4. And then I only have one logarithm. So remember, plus means add, minus means divide. I go ahead and change this into my exponential form. So I'm going to start with my base. My base is going to be 6. And then my power of what it's equal to is going to be to the first, is going to equal then x plus 3 times x plus 4. So we've had problems like this in other chapters, and in this case we've always had it set equal to 0. So you can't say that my log is going to be either -3 or -4 at this point. I've got to get this 6 and move it in. I've got to move it to the other side. So in order to do that, I really need to go ahead and expand this out. So I'm going to start by foiling this out. So it's x squared. I've got the plus 4x plus 3x. That's going to be plus 7x plus 12 is equal to then to 6. And now I need to move my 6 to the other side. So I know I'm going to set it equal to 0. So it's going to be x squared plus 7x. 12 minus 6 is going to be then plus 6. So now I am going to go factors of 6 that add up to 7. Can you factor that for me, Laura, Kristen? X. Factors of 6 that add up to 7. 1 and 6, yes. Now, if you did not see the factored form, what would you do? What could you do? You could put this into the quadratic. It would also give you the same. But remember, I'm going to have plus and plus. Now, my answers then are going to be, right now, I'm going to pull it back up here since I didn't leave room. X is going to equal a -6 or -1. Now, anytime, guys, you have a logarithm, we're going to have to be careful because there are what we call extraneous solutions looming in here. So it's possible you have an extraneous solution. So in this case, I'm going to substitute negative into my equation. So I have the log base 6 of -6 plus 3 plus, I can go ahead, I already see log base 6 of -6 plus 4 is equal to 1. Now in this case, remember what happens if I take inside here, if I have -6 plus -3, that's a -3. And remember, if you take a value of any log to a negative number, what's the answer? Null. So this is a null solution, so is this one. So that means that -6 is actually what we call an extraneous solution because it does not work. So this one is a no solution for a -6. But let me check -1. So in this case, I'm going to go then log base 6 of, I'm going to have -1 plus 3. Then I'm going to have plus the log base 6 of -1 plus 4. It needs to equal then 1. So in this case, I'm going to have the log base 6 of negative, this is going to be the log base 6 of 2 plus the log base 6 of 3 is equal to 1. Now, I would use my rules. Remember, when we add, that means we're really multiplying. So this is actually log base 6 of 2 times 3, which is actually 6, is equal to 1. And we know that works. That checks out. So that means my only solution is going to be negative 1. Now the next one, this heading should have gone to the next one. Use the one-to-one property of the logarithms to solve. So that means, in this case, if I have a log expression, this one-to-one property just means that if I have log base b of some number is going to equal the log base b of another number, then these two numbers have to be equal in order for that to be true. But remember, these numbers both have to be equal, be larger than 0. Same rule that we had just before. So I'm going to start off with this problem here, and before I'm going to do anything, because I've got to get them so that they're in this form, that means I have to combine these two logarithm functions. So because I have a minus, I know I'm dividing, so I'm going to have the log of x plus 7 divided by 3 is equal to the log of 7x plus 1. At this point, I know I have a base, and the base is still 10 because it's assumed, and that means that I can set my the m and the n, equal to each other. So I'm going to start off with x plus 7 over 3 is equal to x plus 7, or 7x plus 1. Any idea what you do first? Yes, you were so smart. Multiply both 3 by 3, and then distribute. So let me go ahead, and since I'm running out of room again, I have the x plus 7 on my left-hand side equals 3 times 7x plus 1, so that's going to be 21x plus 3. And now I'm going to simply solve. So I'm going to move this x to this side, so I'm going to go minus x, and I'm going to move the 3 to this other side, so it's a minus 3. So I end up with 4 is equal then to 20x, and I'm going to divide both sides by 20. So x is going to equal 1/5. And what you'd want to do is just double check to make sure that if you put it back into your equation that it's not going to give you a null solution. So in this case I would do my check. So I'm going to have log of 1/5 7 minus the log base 10 of 3 has to equal the log of 1/5 times 7 plus 1. And so I'd simply go ahead, I'm going to go ahead and put that into my calculator. So I'm going to start off with log, and I'm going to go of 1/5, 1 divided by 5, or you can put the decimal in, and then you can go plus 7. I'm going to close my parentheses, and I'm going to go minus then the log of 3. So I end up with about 0.380. I'm going to write enough of it that I can kind of find it. So then I'm going to go back. I'm going to go with the log of, whoops, I didn't need another parentheses. 1 divided by 5 times 7 plus 1, and close my parentheses. And if you notice, I get the exact same thing. So that tells me that it is an acceptable solution. All right, the last one, we're going to do some applied problems with exponential. And so in this case it says the function p of x is 95 minus 30 times the log base 2 of x. Models the percentage of x of students who can recall important features in the classroom as a function of time, where x represents the number of days that elapsed since the lecture was given. How many days do half the students recall the important information of the classroom, and how many days have all the students forgotten all of the important class lectures? So in this case we're going to start off with half, and so we're going to begin with on the first one. It says he recalls half. So if this is going to be a p, if it's going to end up being the percentage, if the percentage happened to be, in this case, half of the students recall, only half the students recall important figures. So that means that the P of X is going to equal 1/2. So I'm going to put that in, so I'm going to have 1/2 or 0.5 is equal to 95 minus the 30 times the log base 2 of X. And that means I'm just going to have to solve. So this is the first part. So in this case, I'm going to start off with subtracting 95 from my equation. So I'm going to go ahead and change this to 0.5. I'm going to subtract then the 95. And then I'm going to have to, so it would be a negative 94.5 is equal to a negative 30 log base 2 of X. And then I'm going to divide both sides by negative 30. And so now I have a negative 3.15 is equal to the log base 2 of X. And in this case, I can either, I'm going to write it then in exponential form. So I'm going to say 2 to the negative 3.15 is going to equal X. So I'm going to go 2, and then I'm going to go power negative 3.15. I'm going to get an answer smaller than 1. I am going to hold off because I thought I did this one right, but I'm going to go look this one up before because I am getting a funky number.
Okay.
So hold on to this one on A. Yes, on A, I'm going to say that's hard to point one student. So anyway, half the students recall. So let me go ahead and rework this one and see what I've done wrong. But maybe I have the half in the wrong spot. Let me finish with the exponential growth and decay. And I love this exponential. Oh, that's 5. So that will be tomorrow. Sorry.
Okay.
That's why I was missing my 4-5 when I put in my notes, and I'm like, I need to print it again. Sorry about that. So I have got this. So this is the end of our lesson. Let me hold off. I will start with this one tomorrow, but you should be able to get started with some of your lessons. So.